Okay, we're moving into our last section, section 4.4, before you take the second exam. And in section 4.4, we're going to talk about this concept of called concavity, and then also how we put all the stuff together that we've learned to actually sketch curves. So first of all, the graph of a differentiable function y equals f of x is concave up on an interval I if f prime is increasing on that I. In other words, if f prime, the derivative, is an increasing function. Now, if the first derivative is increasing, come down here, that would mean that the second derivative is always positive. That's how you tell if a function is concave up. Now, concave up would be like, picture a bowl. It holds water. That's what the function looks like, concave up. Concave down, the first derivative is decreasing on that interval. Well, that's the same if the function is decreasing. So if f prime is the function we're thinking of and it's decreasing, then that would mean the second derivative would be negative. Okay, so if we're thinking about function f of x, the first derivative tells us whether the function is increasing or decreasing, and now the second derivative tells us whether we have a concave up or a concave down function on a certain interval. Concave down would be like an upside down bowl. It spills water. Okay, so just think about it that way. Okay, so here we are in example 62. We have y equals x cubed. Now y equals x cubed, that's this function right here everybody should be comfortable with. Notice that from negative infinity to 0, from x going from negative infinity to 0, x cubed is actually a concave down, right? Water would spill out of that. From 0 to infinity, x cubed is concave up. It's like you can imagine water would stay in that. Okay, now concave down means that the derivative would be decreasing, right? So here we have a large negative slope and then a less and less negative slope. In other words, the derivative is decreasing because it's large negative, less negative, less negative, less negative, less negative. In concave up, the first derivative is an increasing function because I have a small positive slope and then it becomes a larger and larger and larger negative slope as I travel along this curve. So you can tell that a curve is concave up by whether the first derivative decreases or increases. And then we know from up above that concave down would mean that since the first derivative is a decreasing function, the second derivative would have to be negative. So that would tell us concave down also. Concave up would tell us since the first derivative is increasing, the second derivative would have to be positive in that interval. Now notice here is y equals x squared, which is concave up everywhere, right? That would hold water all the time. Notice way over here, as for x going over towards minus infinity, we have very large negative slopes, then less negative slopes, then less negative slopes, then zero slope, then small positive, then larger positive. So the slope is an increasing function over that whole minus infinity to infinity. Or the second derivative itself is always positive over that whole interval. Okay, I'll stop there.